Hi everybody, this is lesson 2.2, the product rule. Okay, so with the product rule, what we're looking at is finding the derivative when two things are being multiplied. So if I asked you to find the derivative of hx, where h is fx times gx, so that's this times this, so let me just write that out, x4 times x squared minus 5x, okay? There's two ways you can do this. Number one, you can expand the x4 in, okay, and then use the power rule from 2.1, but that won't always work because you will get long and messy equations, okay? So instead, we can use the product rule, okay? So just to kind of show you that they do indeed equal, so in this case, if I were to expand it in, I'll get x6, so multiply that in, minus 5x5, okay? Because x to the power 1 times x to the power 4 is x5. And then if I were to find the derivative of that, I know this is terribly messy, but this is just to prove something. I should get 7 x5 minus 25 x4. Okay, if you're not sure how I got that, review the last lesson, 2.1. Um, well, it's not 7, it's 6. So I should review the last lesson. Minus 25x4. Okay, so now the product rule states this. Instead, what we can do is, for the product rule, now bear with me, I know you're going to look at this and go, well, that just made it more complicated. There's a reason we need to learn this because it shows up repeatedly. It's also another tool. So if you have two things being multiplied, to use the product rule, what you do is find the derivative of the first term, okay? Or, yeah, the first one. So move the 4 down. So I found that this is the derivative of x4, right? And then copy, copy this down. Notice how nothing changed, okay? And then find the derivative of, or sorry, then copy down this plus, copy down the first term this time, but then find the derivative of the second term, okay? So let me repeat that. So if hx equals to x4 times x squared minus 5x, then I notice that there's two things being multiplied, the x4 times x squared minus 5x. So I find the derivative of x4 first, which gives me 4x cubed. Copy down the second term. Copy, nothing changed. Plus, it's always going to be plus. Copy down the first term now, and just swap it, and then find the derivative of what's in the bracket. Move the 2 down. This would be a 1, but you don't need to write the 1. And then this will give me negative 5. The x would be gone. And why is that? So this is just a recap from last lesson. If you have negative 5x1, well, what happens? The 1 comes down. So this is y equals, y prime would equal to negative 5x. 1 minus 1 is 0. Well, anything to the power of 0 is always going to equal to 1. So then you get negative 5 times 1, which is just negative 5. Okay? Negative 5. So then once you're there, if you were to simplify this now, so multiply that in, I'll get 4x5 minus 20x4 plus 2x5 minus 5x4, okay? We'll get 4x5 plus 2x5 is 6x5 minus 25x4. Okay, same answer. Obviously, this seems like a lot more work, but you're going to see why in a second as to why you need to know how to use the product rule. This is the proof, okay, if you want to go through it, or just understand how to do it. So, for example, something like this. So now when we're using the product rule, I know I simplified it up here, okay? But when we're using the product rule now, we're going to try not to simplify it. The reason being, it gets really messy, and the goal here is for you to know how to use the product rule, not know how to simplify. Okay, so if I need to find the derivative of this, if you wanted to multiply and expand this one actually isn't so bad. You can use the power rule, but there will be ones that get messier. But in this case, all you do is using the product rule, find the derivative of the first bracket, which gives you this, right? The derivative of that is 2x minus 4, because you move the 2 down, and then 2 minus 1 is 1. Derivative of 4x is just 4. And then you copied this down. Notice how nothing changed. 2x squared minus 5x, 2x squared minus 5x, plus, now copy down the first term, okay? Copy that down, nothing changed, and then find the derivative of the second bracket. And that's it, and leave it at that. Do not simplify, okay? And that's pretty much what's happening all the way through here. So if I told you to find the equation of the tangent line to the curve, this is just like the lesson 2.1. Again, I see a tangent line, so I need the slope of the tangent line, so I find the derivative. So, see, this is what I mean by expanding it. It could get messy. So the derivative of the first bracket is just 3x minus 5. Copy, copy. Then, copy down the first bracket, and then find the derivative of the second. Once you have all that, okay, now it's at the point 1, negative 2. So, you just replace x with 1 in the derivative, so using a calculator, you can just plug in, replace x with 1, replace that with 1, 1, 1, 1, sub it all in, and you'll get negative 10. That is your slope. So y equals to negative 10x plus b. Then take your point, sub it in, okay, and you'll find that b equals 8. That's your equation. Oops. Plus 8. Okay. And so here are a couple of word problems, okay? So with the word problems, again, you are creating the equation using the product rule. So this is a typical question we see in grade 10, where we are looking at maximizing revenue, okay? So it starts at $140, and then for every price increase, $10 increase in price, so $140, $10 increase in price, and just represents how many times you increase it. 5 fewer people will attend, which makes sense. The more expensive it is, the fewer people will attend. So that's your equation. Now, we're going to find the derivative, dr/dn. So again, using the product rule, find the derivative of the first, copy the second, copy now, plus, copy down the first, find the derivative of the second. Now we are trying to find what is the rate of change in revenue when the price of the trip is $200. Okay. Well, when the price of the trip is $200, right? That would mean, because originally it was 140, that means it was increased 6 times, because 6 times 10 is 60. 60 plus 140 is 200. Or, is set equal to what the price was. Solve for n, you get 6. Which means that at 6 increases, okay, what is the rate of change in revenue? So it's asking, how much more revenue are you getting when you increase it by 6? Okay, or at the time, how much is the revenue increasing per price increase when you have it at 6 increases? So if you sub in 6 into the derivative, you'll get 700. What does that 700 tell us? That tells me that the rate of change is at about, the revenue is increasing at about $700 for every price increase at the time, okay? And how many students are attending? 170, just by subbing in n for 6. Okay, and the last question. You've got a piece of sheet metal, 60 by 30, to make a rectangular box with an open top. Find the dimensions that will give the box the largest volume. So we got to find the volume first, which is length times width times height. So if I know that this is 60, then this distance must be 60 minus 2x. If I know that this is 30, then this must be 30 minus 2x. That will give me the length and the width of the box. And the height is just, now picture this being folded upwards. Okay, that will give me the height. Now I have 3, things to find derivatives of, but it's the same thing. So first off, I found the derivative of the first bracket, copy the other two, then plus found the derivative of the second bracket and copied the other two, then found the derivative of the third one, which is just an x. So what's the derivative of just x? Well, it's going to be 1, which means there's technically a 1 there, and I just copy down the other two brackets. Okay. Now from here, I do have to simplify in this case, okay, because it's asking us to find when the derivative is 0. Okay. Why am I trying to find when the derivative is 0? Okay. So the reason for that is we're looking for the largest volume, right? So I'm going to try to draw a quick visual for you. This is going to end up being a quadratic. Okay, so if I expand this and simplify it, I end up with this equation, which is a quadratic. Okay, so let me just double check something here. Okay, so if I'm looking for when the tangent is 0, that would mean I'm trying to find when this, because why am I finding where the tangent is 0? Looking for the largest volume. So if I were to look at this originally, sorry, I was looking at the wrong one. There we go, there's the volume. Okay, so if you look at the volume, right, there's an x, there's an x, there's an x, which means this is a degree 3. Okay, again, I'm going to draw the sketch, but it's not representative of this function. It's just to show you what a cubic could look like. Okay, so that could be the general shape of this graph. It's a third degree. If we're looking for maximum volume, well, that looks like it can give me a max, right? Well, if I look at that point, what's the slope of the tangent there? Is it not just a flat line, right, to touch that one point, which will give me a derivative of 0? Now, you're right, there's also this point. Okay, this would technically give me minimum, wouldn't it? So I need to set it equal to 0, and yes, I will end up finding 2 answers, okay, which I did. So once we got here, we divided everything by 12, tried to factor it, didn't work, so I used the quadratic formula, okay, and I got 2 answers. Yeah, I got 2 answers, 6.34 and 23.66. So 6.34 is probably there, and 23 point whatever that was, 23.66 is the other one. Okay. Now, however, only 6.34 makes sense and not 23, because think back to the context of the question. If this distance was 23 and this was 23, well, 23 plus 23 is 46. I only have 30 centimeters to work with here. So this answer is not possible anyway, right? Which, if you look at the graph, doesn't give me a max anyway, okay? All right, any questions? Feel free to send me an email. And yeah, we'll chat soon. Take care.